form at 32 degrees or colder, okay? But in the air, water can remain as a liquid at temperatures well below that. But if you put an object, a surface, into that cloud, what we have is an instantaneous ice up, okay? In other words, the ice will come in contact, the water will come in contact with your aircraft and thus build up ice on the wings, and that causes a lot of problems for steering and, of course, weight as well. And this is a very, very dangerous phenomena, and we've really only known about it for about the last 40 years. We had a terrible tragedy with icing conditions back about 1980. You can see the plane there in the upper right-hand corner. This was an actual aircraft that was carrying the University of Indiana's basketball team to the NBA tournament. And this plane, housing most of the players and some of the fans, came to a very, very abrupt end when it crashed to the ground because it ran into a cloud of what we call supercooled water. And that supercooled water was water that was below the freezing point, but when you put the plane inside that cloud, it instantaneously took that water and it caused it to become ice on the cloud, on the aircraft itself. This increased the weight, it slowed the aircraft down, it decreased the lift, and the plane came crashing to the ground, killing all on board. A very, very sad day, but a very important lesson about icing. So if we're launching a rocket ship, we're launching any rocket, we have to be very careful that we do not have clouds that contain supercooled water. The other thing about clouds is that sometimes they're so thick that, even though they do contain freezing temperatures, and they might be safe to fly in, you lose the visibility of the vehicle. And that can be dangerous too, especially if there has to be an abort. So that is something that we have to keep in mind. Another thing is that we do not launch in sub-freezing temperatures. We learned a very painful lesson in 1986. The Challenger, which launched in January, hit it was stored in some very, very cold air at the surface. And the Challenger, again, was the space shuttle that carried the first teacher in space. And of course, the rest is history. We believe the investigations tell us that because of the temperatures being so cold, the O-rings in the fuselage did not expand and contract enough. They weren't flexible enough. There was a leak and a tremendous explosion. And that caused the death of the 7 astronauts on Challenger. So again, a very important lesson learned, just like the icing was learned back in 1980. So the bottom line is the responsibility for following the weather and giving conditions, reporting conditions that are safe for launch goes to the U.S. Space Force's 45th Weather Squadron, okay? The caption on the right here was just before the April 23rd launch, okay? So they were asked to, the launch was canceled a couple of days before. The next report out for a April 23rd launch, the U.S. Space Force's 45th Weather Squadron predicted a 90% chance of favorable weather conditions at the launch for liftoff, based on the requirements for the Falcon 9 Crew Dragon. That's the Crew 2, second one. So the conditions are expected to improve along the flight path, recovery area, yada, yada, yada. So they gave it permission for launch as far as for the weather, okay? Now, what's also interesting about the Space Force, we had some history in the making. The first time in history, it was an all-female weather team that was responsible for the launch of the Crew Dragon. So that was pretty significant. So again, a definite historic launch. And that was the last major launch. And some of you may have caught it on TV and maybe watched the launch on NASA TV. But the bottom line is it was an all-female crew, and that was pretty significant. And these are the astronauts that are right now on the space station. And you may have talked to at least one of them, I think Megan MacArthur. a little bit earlier today when we hosted, you hosted the NASA uplink. So anyway, these are the astronauts on board now. They are some of them. There are 9 astronauts there in total. So it gets a little crowded on the space station. Okay, so the bottom line is, what do we look for weather patterns that are good for launch? Meteorologists always look for clues, okay? And they are not only from the Space Weather Squadron, but a lot of commercial meteorologists get into the fray as well. And they look for clues that help point to a go or no-go situation. So the young lady there on the right is Caitlin Napoleone, and I think some of you are going to be tuning in for her webcast in a little while. But overall, we look for particular patterns. Most of you have seen weather maps. You've seen all kinds of patterns there. You've gotten to know some of them: high and low pressure systems, passing fronts, humid air, and large pressure changes. We could have also add warm air as well. But the bottom line is that meteorologists look for clues that will help us predict the weather so that you can forecast 24, 48 hours in advance whether you're going to have safe conditions for a launch, okay? So let's take a look at some of these. And number one, we'll look at the high pressure system. High pressure system are domes of sinking air. And usually, if you have a high pressure system sitting right over the top of you, then this is considered to usually be the best weather for a launch. High pressure sitting over you has very light winds. The air is usually clear and dry, and the winds are generally calm straight up through the column. So that is a good sign. So if you see a high pressure system, you're going to be very happy if you have to launch a missile. Low pressure systems, on the other hand, often bring stormy weather, and they often also bring changing wind directions. They also produce things called fronts, and we'll get into that in just a few minutes. But as you can see, that low kind of spins counterclockwise and toward the middle, and then the air also, when it kind of gets into that direction, it rises. And so there's a lot of turbulence in an area of low pressure, and if a low pressure area is coming across a launch site, you probably want to reconsider launching it until maybe a high pressure system moves in behind it. But overall, low pressure system usually brings stormy weather. Now, fronts are usually also areas of active weather, unstable weather, we call it. A cold front very often brings showers and thunderstorms. The clouds build up very tall, and sometimes you also get some very strong winds. We also can get on a cold front, especially in places like Texas and Florida, you get severe weather conditions like hail and sometimes even tornadoes. Now, on the other side, we have warm fronts. Now, warm fronts usually don't bring you as tumultuous of weather as the cold fronts, but when the warm front comes in, it generally brings steady rain, and it also brings long duration rain. So in other words, if it's raining at 9 o'clock in the morning and a warm front's going through, it's probably going to be raining at noon and maybe 2 o'clock as well. So that usually brings long duration weather events. Now, as far as humid and unstable air, that's another one. Air likes to rise kind of almost by itself, and it doesn't take a lot to lift it. And lifting air causes cooling, and cooling causes condensation, clouds, and usually some very turbulent weather along the way. If you have unstable atmosphere, you can also get showers and thunderstorms, and some could be potentially severe. So you want to watch out for the stability of the atmosphere as well. Another thing you want to watch out for, what we call large pressure gradients. Pressure gradients are fast changes in the pressure. As meteorologists, we look at lines of equal air pressure. We call those isobars. And when the isobars are far apart, it means that the change is very low, isn't very great. But if the isobars are close together, that means you have fast winds. And as you know, fast winds are not good for launching a rocket, okay? So you want to keep an eye on high pressure systems where we have, or low pressure systems where we have isobars that are close together. Radar images tell us an awful lot as well. We have new technology right now that is far surpassed the old Doppler radar. We call it the dual pole. And the dual pole is so sensitive they can show the difference between rain and hail and snow. And they can also see flying debris. If a tornado goes over an area and picks up roofing shingles, you can determine that with the new radar that we have out there. So it's pretty significant. So meteorologists look at all of these clues to determine whether or not it's safe for a launch. So what we're going to do today is give you a turn at trying to decide whether or not it's safe to launch. We're going to give you a couple of launching sites here. Let me move my thing out of the way. I'm going to bring it up to the top here so you can see. We have Florida down there on the east coast of the United States. That's in yellow right there. And then we have Texas in red. I'm going to go to my pointer here. And there we go. And so here's Texas, there's Florida. Florida's yellow, Texas is red. And these are launch sites. The NASA craft generally launch from Florida, and the commercial craft often launch from Texas. So we'll give you those two places, all right? So if we were going to launch in this particular scenario here with the weather map, right here in Texas, we have a frontal system, okay? We call that a stationary front, but again, a front means that weather can be turbulent. We have a lot of rain. That's the dark green here, okay? That's right over the launch site. And over in Florida, we have a cold front going through, and that front also usually means rain, showers, and probably changing winds as well, okay? So that's the name of the game. So let's go to play. Let's go to our next image. And these are real images right now. Here we have Texas, and here we have Florida. Now, if you were going to be launching a spacecraft from Texas or Florida, which site would probably be the safest weather for the launch? Would it be Texas or Florida? Think about it. What do you think? Okay, I can almost hear you. Over here in Florida, we have isobars that are far apart. We probably have an area of high pressure right there and clear skies. We don't have much in the way of anything going on. So probably Florida is a pretty good spot to launch. Texas, however, we've got a cold front, and cold fronts are going to be moving toward Texas. So this area is probably going to be one that we'd have to kind of keep an eye on because the weather there might be a no-go for a launch. Okay, let's try one more. Okay, so we have Texas and we have Florida, okay? Notice that we have a front going right through Florida, and if this is the time of the launch, that may not be a good time to try to put a rocket into the air. However, in Texas, we had a front that kind of slipped through, and that front probably means that the weather with this high will give you pretty nice launch conditions after that, okay? So let's go to another one. How about this one? Do we launch from Texas or do we launch from Florida? Well, I think the fact is that Florida seems to be in the clear here with very little action going on. We have a front that's going toward Texas, and depending on how fast that front goes, that could impact launch weather if you're going to be doing it in the next few hours. Okay, so let me go up into get some chats here. And okay, so we got responses. You guys have done really, really well. So I'm just going to type, whoops. So you guys have paid attention, and you've done really, really well on the quiz. So you all get 100. Tell your teachers to make sure they do that for you. And oh, we have some more here. Oh, wow. Oh my goodness, look at them all. Wow, yes. I think we scored 100 on that exam. I think everybody that attended this session should have at least a 100 on a quiz grade because you guys are perfect. I think some of you guys might want to become interested in becoming a meteorologist, And if you go into the service, some of you might even, get into the space weather squadron. All of these jobs are very, very rewarding. So yeah, I'm looking at names here. Alania, I see Charlotte, I see Pyra. I've got Evan Imhoff. A lot of these names are familiar. I taught school here for a long time. So, but yeah, you guys have done a fantastic job. And let me go on to my next thing here. And let me turn the chat off for just a second and move forward here. Okay. Well, I'm almost to the end here. I've got to be able to. There it is. Now, let's do some questions that may not have anything to do with launch weather. If you have any questions out there right now, I don't know how much time I have left, but I think I'm probably getting very close. So if you have any other questions about weather, space launches, or anything like that, you can feel free to email me through, I guess, Erica and Plattsburgh State, or even your own teachers at school. Erica, you want to join us?
Sure. Any questions right now, you can send through the Q&A or the chat, doesn't matter, but the Q&A will be a little bit easier to see if everybody starts sending them at once.
Okay, well, I got a couple.
Give just one thing though. If you
Yep.
send something in the chat, just make sure it's to all the panelists and attendees. You're sending me a couple different direct messages.
Oh, okay. I'm sorry. I'm
That's
sorry.
all right.
Yeah. Okay. So I've got a couple of questions here. How big can clouds get? I guess everybody can hear me. They can get over 70,000 feet tall. That's huge. That is almost to what we call the troposphere. Okay. What do I like about my favorite part about being a meteorologist? It's sort of like a game you play against Mother Nature. Okay, it's sort of like a gambling game. You've got the data, you've got the observations, and you're trying to outguess Mother Nature. Sometimes it works, sometimes it doesn't. But if you study all the patterns, it's a rewarding thing in that sense. Also, being able to warn people, give them enough time to prepare for severe weather. That's a very rewarding part of it, because if you're forecasting a major snowstorm and you have a big snow day the next day, you feel pretty happy about that, especially when you're a teacher. Anyway, let's go to tornadoes anytime soon. Not here. We average in New York State about 5 or 6. They usually occur in the summertime. When the air is cool like this, you don't really ever expect a tornado. How long before a storm do you know? How long before a storm? Sometimes you don't have much time at all. Thunderstorms are the biggest puzzle. Sometimes they pop up almost at a moment's notice. And sometimes you have lots and lots of warning. In other words, a big storm is coming. The bigger storms are a lot easier to forecast because you do have the length of time ahead to look at all the data and make the storm a prediction. But thunderstorms and tornadoes are really pop-up things, and they occur almost at a moment's notice, and they can be very, very dangerous because of that, because you don't have a lot of time to give a warning. Have I ever seen a launch in person? No, it's on my bucket list. I have some friends in Florida that want me to come down. Haven't had the chance yet, but I wanted to. Back in 1982, as a matter of fact, I was actually an applicant for the Teacher in Space program. I've always been interested in space. Another question is how many launches are, well, wait a minute, let's go back to the cyclone. First of all, the word cyclone has got a couple of meanings that are kind of different. A cyclone is any low pressure system in mid-latitudes in the United States. In other words, a cyclone has counterclockwise inward and upward moving air. Now, cyclones are also hurricanes, and those cyclones usually occur in the Indian Ocean. okay? If you go out west, a cyclone is also a tornado. So it's kind of a confusing term. So we usually think of cyclones as low pressure areas that go across the United States. Any low is a cyclone, okay? So what's more dangerous, a cyclone or a tornado or a hurricane? Well, it all depends. However, hurricanes kill more people by flooding, and tornadoes kill more people by debris. So that's something to keep in mind. Hurricanes are much, much larger, much more energetic features. Tornadoes are much narrower, much smaller. And though they do a lot of damage, the damage is only to usually within a mile of diameter and maybe 4 or 5 miles of length. Hurricanes devastate huge parts of the United States and other countries as well. Have I ever been a storm tracer? Yes, back in the 1990s, I worked with a project called Project Vortex 1. And the idea was to study tornadoes and how they moved. And so we went out to Kansas City and we studied out there. We went to the National Severe Storm Center in Norman, Oklahoma, and we studied there as well. And, in 2 years or 2 summers of chasing, with all the best equipment, honestly, we never saw one. We saw them on the radar. We raced to them as fast as we could, never got there in time. And that'll give you an idea of how ethereal these tornadoes can be. Why did you become interested in meteorology? Well, in the beginning, I really wasn't all that interested. Well, I didn't get interested in meteorology until I became a teacher. I was a geologist before I started. I worked up in Canada, and it was through teaching that I got into doing the weather for WPTZ, and I've been there for 37 years. That's hard to believe. I'm hearing pizza is there.
All right. So I hate to do this, but this is just about the end we have for this workshop, everybody. Gib Brown, thank you so much. It was amazing.
Thank
As you
you.
can tell, we have lots of questions, lots of kids interested in the weather.
Oh my God. I wonder if that's Caden, my grandson, that's there. Hi, Caden.
Everybody
Anyway.
have a great day. I hope you had so much fun. If you are joining us for the next workshop with Miss Caitlin, you're more than welcome to stay. We might just do a couple little checks. If you're going
It's
to a
going to be a
different
great
workshop, have a great day.
Thank you very much,
Thank
Erica, for
you.
running such a great thing, and all the people out there that have been watching. Thank you, and keep studying. Remember, math and reading, big ones.
Let me get this a second. Caitlin, I'm just gonna end this really quick and then we can pop back in, okay?
Yeah, sounds good.
All right.
Hi, Caitlin.
Hey, Gib.